This video is for ELEC 1510 Logic Design. This is Lecture 15, Part 2 on J, K, and T flip-flops. This corresponds to textbook section 5.4. A JK flip-flop is a different type of flip-flop that's constructed out of a D flip-flop and some additional gates. The D flip-flop only has one input D, but the JK flip-flop has two inputs J and K. No one really knows what the J and K stand for or why J and K are used. It's kind of lost to history why they're called that. The equation for D in terms of J and K is from this AND gate, JQ prime, then plus, because there's an OR gate here, K prime times Q. All right, so by being able to tell what the data input is, we can tell how the flip-flop is going to behave. When J and K are both 0, that means that 0 times Q prime gives 0, plus 0 prime, that's 1, plus Q gives D being equal to Q. So Q of T plus 1 then is just equal to Q. When J is 0 and K is 1, that means 0 times Q prime is 0, plus 1 prime is 0 times Q means D is 0 and Q is 0. When J is 1 and K is 0, in the equation above, that gives us 1 times Q prime is Q prime, plus 0 prime, that's 1, times Q, so that's Q prime or Q, which is 1, so D is 1, meaning Q of T plus 1 is 1. When J and K are both 1, that gives us Q prime plus 1 prime, that's 0 times Q, so D of T is Q prime, and Q of T plus 1 is Q prime. That means that Q of T plus 1 is the complement of whatever Q used to be. So we have a couple names for these settings. There's no change, NC. There's 0, which is reset. There's 1, which is set. And then Q prime, which is toggle. So JK flip-flops have all of this functionality. We can either store data with no change, we can reset the output to 0, we can set the output to 1, or we can toggle the output by keeping J and K both equal to 1. The circuit symbol for a JK flip-flop looks like this. It's a block with the inputs J and K, a clock line with a triangle next to it, and a single output Q. The characteristic function table for a JK flip-flop is given here. Again, J and K both being 0 indicates no change at the output. J and K being 0 and 1 respectively indicates that the output is reset, that means 0. J being 1 and K being 0 means that the output is set to 1, and J and K both being 1 means that the output toggles. A T flip-flop is an additional type of flip-flop that we can construct out of a JK flip-flop. T, in this case, stands for toggle, and the T flip-flops are used exclusively for functions that involve toggling outputs, like clock generation, for example. In the diagram here, you can see that the T flip-flop has only one input, T, which is connected to both J and K for a JK flip-flop. This means that in the truth table, T can only be 0 or 1, and J and K can't be different, so we get rid of those lines in the JK flip-flop where it's different. When J and K are both 0, D of T was equal to Q for the JK flip-flop, meaning Q of T plus 1 is equal to Q, indicating no change. When T is 1, that means that both J and K are 1. For the D flip-flop, that means that D is Q prime, And then q of t plus 1 is equal to q prime, which indicates toggling. So the t flip-flop can only have two possible states, no change or toggle. The T flip-flop circuit symbol looks like this. It's a typical flip-flop block with the clock input and the triangle. The only input is T and the only output is Q. Its characteristic equation looks like this, where when T is a 0, Q of T plus 1 is no change, meaning it's equal to Q of T. And when T is a 1, Q of T plus 1 is the complement of Q of T, which means that you toggle the output.